Good day, esteemed researchers and curious minds tuning in from around the globe. We're diving into the fascinating world of explainable few-shot knowledge tracing. This groundbreaking research aims to revolutionize traditional knowledge tracing by leveraging the power of large language models. It presents a novel cognition-guided framework, promising to enhance our understanding of learners' knowledge states while providing insightful explanations. Stay tuned as we unravel how this could reshape education and beyond. Let's begin. Our research aims to bridge the gap between conventional knowledge tracing and real teaching scenarios. We leverage large language models, or LLMs, to achieve this. These models, with their vast parameter space and emergent abilities, can handle complex tasks and provide natural language explanations, making them ideal for this task. However, we must acknowledge the limitations of existing approaches. Current models primarily serve as the cognition module, modeling learners' knowledge state and predicting performances. They struggle with extensive student exercise records due to task-setting limitations. This is where our research comes in, aiming to overcome these limitations and enhance the performance of knowledge tracing. Our research introduces a novel cognition-guided framework, a system that integrates three fundamental components: observation, cognition, and interpretation. This framework leverages the power of large language models, or LLMs, to unify the cognition and interpretation components, creating a cohesive system that can handle diverse data. Now, let's talk about the performance of these LLMs. Our findings show that they can achieve results that are comparable or even superior to competitive baselines in conventional knowledge tracing tasks. What's more, they provide more natural language explanations, enhancing the understanding of the process. But we're not stopping there. We see potential for even greater performance. With further refinements and a deeper understanding of their predictive mechanisms, we believe that LLMs can significantly enhance the field of knowledge tracing. This is an exciting time for the intersection of AI and education, and we're thrilled to be at the forefront of this research. Our research is driven by the recognition of a gap between conventional knowledge tracing and real-world teaching scenarios. We've noticed that existing models often struggle with handling extensive student exercise records. To address these issues, we've developed a cognition-guided framework for explainable few-shot knowledge tracing. This framework, as depicted in the figure, is designed to better understand and predict student performance, while also providing clear explanations of the assessment process. This innovative approach aims to bridge the gap between theory and practice, enhancing the effectiveness of knowledge tracing in diverse learning environments. In the realm of knowledge tracing, previous work, such as that by Nashai et al., has made strides in extending the capabilities of large language models, or LLMs. However, these efforts have been somewhat constrained by the limitations of traditional knowledge tracing task settings. To address this, we propose a novel solution: a cognition-guided framework for explainable few-shot knowledge tracing. This framework is composed of three key modules: observation, cognition, and interpretation. Each plays a crucial role in defining the task scenario, modeling learners' knowledge state, predicting performances, and providing explanations of the assessment processes. What sets our approach apart is the innovative use of LLMs to unify the cognition and interpretation modules. This integration forms a cohesive system capable of handling extensive student exercise records. Moreover, it provides natural language explanations, enhancing the understanding and interpretability of the knowledge tracing process. This innovative approach opens up new possibilities for the application of LLMs in the field of education. Our research introduces a novel approach to explainable few-shot knowledge tracing. We've developed a technical framework that integrates selected student records, a predictive model, questions, and knowledge concepts. This framework not only estimates the knowledge state of a student, but also generates explanations for these estimations. This dual functionality provides a comprehensive understanding of a student's learning progress, making our approach a valuable tool in the field of education technology. Our research introduces a cognition-guided framework for explainable few-shot knowledge tracing. This innovative approach leverages the power of large language models, or LLMs, to enhance the process of knowledge tracing. The proposed framework is composed of three integral components: observation, cognition, and interpretation. The observation component is responsible for defining the task scenario and gathering the necessary data. The cognition component then takes this data and models the learner's knowledge state, predicting their performance. Finally, the interpretation component provides explanations of the assessment processes. What sets our framework apart is the way it unifies the cognition and interpretation components. By leveraging LLMs, these two components can ingest the diverse data collected by the observation module, integrating all three components into a cohesive system. This approach not only enhances the process of knowledge tracing, but also makes it more understandable and accessible. In our research, we harness the power of large language models, or LLMs, to revolutionize the field of knowledge tracing. These models, with their emergent abilities, can understand complex instructions and solve intricate tasks. They are capable of reasoning using multi-dimensional information and generating natural language responses, making them ideal for our purpose. We've also formulated a new approach called Explainable Few-shot Knowledge Tracing. This method integrates selected student records, a predictive model, questions, and knowledge concepts with extended information. The result? An output of estimated student states and generated explanations. This innovative approach allows us to better understand and trace the knowledge acquisition process of students, providing valuable insights for educators and researchers alike. Our research introduces a novel approach to knowledge tracing, one that is not bound by the constraints of traditional task settings. This framework is capable of handling extensive student exercise records, a challenge that has proven difficult for previous models. But we're not stopping there. We believe that further refinements and a deeper understanding of the predictive mechanisms of large language models can significantly enhance performance. Moreover, our framework has the potential to be extended to new tasks. Imagine applying this to open-ended question answering or programming knowledge tracing. The possibilities are vast and exciting, opening up new avenues for exploration in the field of educational technology. Our research has yielded some key results that we're excited to share. Firstly, large language models, or LLMs, have shown comparable or even superior performance in conventional knowledge tracing tasks. This is a significant finding, as it demonstrates the potential of these models in educational contexts. Secondly, LLMs have proven capable of providing more natural language explanations under our proposed framework. This means they can not only perform tasks, but also explain their processes in a way that's understandable to humans. Thirdly, we believe that LLMs have the potential to significantly improve knowledge tracing tasks. Their ability to understand complex instructions and solve complex tasks could revolutionize the way we approach education. Lastly, our proposed framework isn't limited to conventional tasks. It can be extended to new tasks like open-ended question answering and programming knowledge tracing. This opens up a world of possibilities for future research and applications. In summary, our research shows that LLMs have a lot to offer in the field of education, and we're excited to see where this journey takes us next. In our research, we formulated a new task, Explainable Few-shot Knowledge Tracing, which serves as a bridge between traditional knowledge tracing and real-world teaching scenarios. This approach allows us to better understand and track a student's knowledge over time, providing more contextually relevant and natural language explanations. As you can see in the figure, we've compared the performances of GLM-4 and GPT-4 on the FERC-sub and MOOC radar datasets using the first 4 few-shot. The results demonstrate the potential of large language models in this domain. In conclusion, our work opens up new avenues for enhancing the performance of these models, making them more effective tools for understanding and guiding student learning. We've introduced a cognition-guided framework that leverages the power of large language models, or LLMs. This framework is composed of 3 key components: observation, cognition, and interpretation. In terms of performance, LLMs have shown to be quite impressive. They not only match, but often surpass the performance of competitive baselines. What sets them apart is their ability to provide more natural language explanations, enhancing the learning experience. Looking ahead, there are several ways to further enhance the performance of LLMs. One promising approach is to provide more informative, relevant few-shots. This could significantly improve the model's ability to understand and predict student knowledge. Lastly, let's not forget the remarkable capabilities of LLMs. They can understand student essays, programming codes, and even multimodal inputs. This opens up a world of possibilities for their application in education and beyond. Our research has extended the concept of explainable few-shot knowledge tracing, encouraging its application to new tasks such as open-ended question answering and programming knowledge tracing. This opens up exciting avenues for future exploration. We've also highlighted the need for more exploration in utilizing large language models, or LLMs. There's a wealth of potential here for further refinements and a deeper understanding of predictive mechanisms, which could significantly enhance the performance of these models in knowledge tracing tasks. Finally, we've seen significant accomplishments in other fields through the application of LLMs. This suggests that similar success could be achieved in the field of knowledge tracing, offering promising prospects for the future of education technology.